Hello friends, welcome to the video lecturing class of low speed aerodynamics. So today we are discussing the supersonic wind tunnels. So already we discussed the subsonic as well as the transonic wind tunnel in the previous video lecture. So now we are going with the third one, that is a supersonic wind tunnel. So supersonic wind tunnel, so as the name suggests that it is operating in the supersonic range. So right from Mach number 1.2 to the Mach number 5 is operating range. So in this range the design is preferred, and based on the different velocity, the design has been preferred. So here we are discussing the supersonic wind tunnel. Here based on the open type as well as the closed type wind tunnels are there based on the requirement. So basically when we see the wind tunnels, so in the both cases, the open as well as in the closed wind tunnel, so we have the intermittent supersonic blow down wind tunnel. That is the first category. The next category will be indraft wind tunnel. So when we see about the intermittent blow down wind tunnel, so already we have shared the notes with you people. So I have the diagram with respect to this one. So this is the components of intermittent supersonic blow down wind tunnel. So as it indicates over here that first I'll explain the parts related to it. So first this will be the part. So this is the high pressure air storage, and then next will be the pressure regulator that is working in the higher ranges. So high pressure regulator, and then third one will be the settling chamber, right? So the third one will be the settling chamber, and then the fourth will be the nozzle. So here you can see that the nozzle, fourth one will be the screen. So as you can see over here that the screens are provided here, the screens, and then the nozzle, the fifth part will be the nozzle, and then sixth part will be the sonic throat. So here you can see that the name has been mentioned here, sonic throat. And then the test section, which is very important role here, so which is very important. And then the eighth section will be the secondary throat, and then ninth will be the diffuser, which is main important, and they're either deaccelerating the air. And then the 10th one will be the low air pressure chamber. So here you can see that tank number 1 and tank number 2. So when it comes to the supersonic wind tunnel, so you have to prefer that whatever amount for testing, the amount means whatever the time, whatever we are getting here in the supersonic wind tunnel, it will be very less when it comes to the closed as well as the open, or in the intermittent wind tunnel or in draft wind tunnel. So the time whatever we are getting is very less, and it is expensive when compared to the subsonic wind tunnels. So as I mentioned, the open type as well as closed type, both are now both circuits based on the design. So generally we are taking the type of a closed one here. So here you can see that the tank number 1 and tank number 2 are connected through a segment. So here different segments, what I can say here. The first one is the higher pressure air storage. So high pressure air is there one side, and the low pressure chamber is there one side. So in between we have the test section and convergent divergent kind of a nozzle arrangements. So when it comes to the higher pressure, so as we are already know that the energy will transfer from higher level to the lower level. So here whatever the tank number 1 is having the high pressure chamber. So usually when you are designing the supersonic wind tunnel, you have to take care for the chamber, pressure chambers.